In this problem, we are going to set up the integration to find the volume in both orders of integration, and then we will understand, looking at our setup, which one is the better way to integrate and get the volume of the given three-dimensional figure. So let's first talk about the area over which I'm trying to find the volume. So in my Cartesian coordinate system, we're going to get the different pieces. First, we have the line y equal to x. Then we have the line y equal to 6x. Then we have x equal to 1, so it should be somewhere here. And finally, we have x equal to 6. So the region we are interested in is going to be shaded this way. Now, when I'm trying to find the volume of this thing, as I said, I can either integrate y first or I can integrate x first. If I'm integrating with respect to x first, I have to be a little careful. Why? Think about abscissa-wise, you have two different portions of the volume that you are interested in. If you think about this line that I have just drawn, at x equal to 1, this point here is going to be 1, 6. And this point at x equal to 6, because it is crossing the line y equal to x, is going to be 6, 6. Under this line, the volume, the portion of the volume will be evaluated on this triangle. So if I consider an arbitrary line to understand the limit of my x coordinates start at x equal to 1, goes all the way to the line y equal to x. So I will say that it is going to x equal to y. And the function I'm integrating is y over x squared plus y squared. And this is with respect to x. Then I integrate this with respect to y. And the limits of y in this little region, your y value is going to start at this point. And remember, this is the point where the x equal to 1 line crosses y equal to x. So the point is 1, 1. So the lowest y value is 1, and the highest y value, because I'm stopping here, is 6. And that's only the region under the line that passes through 1, 6 and 6, 6. Now we are interested about the other portion. This time, the value of x starts at the line y equal to 6x. So x is equal to y over 6. So that's the lowest value of x. And it goes all the way till it reaches the line x equal to 6. So that's the upper limit. And again, I'm integrating the function y over x squared plus y squared with respect to x. And then I go ahead and integrate with respect to y. For this portion, the value of y, the lowest possible value is the line 6, because I'm starting here. And the highest possible value of y is this point, which is the crossing of x equal to 6 and y equal to 6x. So this point is the point 6, 36. So the highest value of y is 36, and I do the integration with respect to y. So both of them, when done and I added, I get my required volume. This is when I integrate with respect to x first. Now let's think about the situation one more time. So again, I have the line y equal to 6x. I have the line y equal to x. So y equal to 6x, y equal to x. And I have the line x equal to 1. And I have the line x equal to 6. and I want to know the volume over the integration region, which is shaded this way. This time I want to integrate y first, so we are going to see an arbitrary situation for the limits of y. And see, for the entire region, your y values are going to start on the line y equal to x. And it is going to end on the line y equal to 6x. And we will integrate the function y over x squared plus y squared. And I'm integrating with respect to y first. Now I am interested in the limit of x. Since this point can vary from this point over here to this point over there, which has the x value of 1 and 6, I will say the limits of x is 1 and 6, and then I integrate with respect to x, which gives me the exact same volume. But as I have shown, the second integration is much easier because I'm integrating less in this type of problem. So let's complete this integration and find the volume. Integrating with respect to y first, I will remind myself that x terms are constant. So what I do, I go ahead and substitute x squared plus y squared equal to z. That tells me with respect to y, when I find the derivative, 2y dy is equal to dz. So y dy is equal to dz over 2. What else? I have to talk about the limits. I'm changing from y to z. Limits for y was x and 6x. If I put y equal to x in my expression, my z becomes x squared plus x squared, which is 2x squared. If I put y equal to 6x, my z become x squared plus 36x squared, which is 37x squared. So these are my upper limit and lower limit. And I rewrite this integration as 1 to 6 integration 2x squared to 37x squared. And the function I'm integrating, remember y dy, that term together is now dz over 2. And the term on the bottom is your substitution, z. So the integration has become much easier. Take this constant 1/2 out, and you get integration 1 to 6 dz over z, with the limits of integration being 2x squared to 37x squared dx. So let me write it one more time because I'm confusing myself the way I'm writing the limits. I'm going to write it one more time. So this is 1 to 6 2x squared to 37x squared dz over z dx, and the constant 1/2 is out. So dz over d is natural log of z. So I get 1/2 integration 1 to 6 natural log of absolute value of z dx, and then I have the limits of 37x squared and 2x squared, which is 1/2 times integration 1 to 6 natural log of 37x squared. Because x squared is positive, I can forget about the absolute value sign, minus natural log of 2x squared. Similar reason, don't have to write the absolute value sign anymore. Then I'm going to use the power rule of natural log first and write it as 1/2 integration 1 to 6 2 times natural log of 37x dx minus 1/2 integration 1 to 6 2 times natural log of 2x dx. I should have said square root of 37x and square root of 2x. Just think about square root of 37x whole to the power 2, you get 37x squared. So using the natural log, I brought this power outside. And then I will have to do integration by parts on both of these integration to get my final answer. So I will start by saying 1/2. First, you will fix the 2 times natural log of 30 square root of 37x fixed. So you will get times 2 times natural log of square root of 37x, and you will do the integration of the function 1, which is going to give you x within the limits of 1 and 6 minus 1/2 times. Now I'm going to do integration 1 to 6. You take the derivative of natural log of square root of 37. So I already have this 2. Derivative of natural log of square root of 37x is 1 over square root of 37x times square root of 37. And integration of 1 has given you x dx. So this is just the first integration in the last step. Then I have minus 1/2 times, similarly you get 2 times natural log of square root of 2x times x, limits are still 1 and 6, minus times minus. So there is a minus in the integration, minus from the integration by parts formula, so that will become 1 plus positive 1/2, integration 1 to 6. 2 times derivative of natural log of square root of 2x is 1 over square root of 2x times square root of 2 times x dx. So we will simplify this expression now. And let's see what we get. So the 1/2 and the 2, they will cancel each other, and I will get natural log of square root of 37x times x between 1 and 6. When I'm doing the second part in the integration, I will cancel the square root of 37 with the square root of 37. The x can be cancelled as well, so I just have negative 1/2 times 2, which is 1. Integration dx is x. So I will get integration 1 to 6 of dx, and I will get x from that. So that's minus x between 1 to 6. Then the next bit is negative 1/2 times 2, so cancel them, and you get minus natural log of square root of 2x times x, and limits are 1 to 6. And then I'm going to talk about this integration here. Again, you can cancel the square root of 2 and square root of 2x and x. 2 and 2 will cancel each other as well, like it did in the last one. So I get a positive integration of dx is x 1 to 6. So as you can imagine, I will now cancel this negative x 1 to 6 and this positive 1 to 6 and evaluate the rest. So what I get when I put in 6 times natural log of square root of 37 times 6 minus, now we are going to put in 1 for our limit, and I will get 1 times natural log of square root of 37 times 1. From the other function, I get minus 6 times natural log of square root of 2 times 6, minus times minus is a plus, 1 times natural log of square root of 2 times 1. So now use this thing and this thing together, use the quotient rule, and you are going to get, if I factor out the 6, it's natural log of square root of 37 times 6 over square root of 2 times 6, so I can cancel the 6 terms. Similarly, if I factor out minus 1, I get natural log of square root of 37 times 1 over square root of 2 times 1. So my answer becomes 6 times natural log of square root of 37 over 2, I put them under 1 square root, minus natural log of square root of 37 over 2, which is 5 times natural log of square root of 37 over 2. So we wanted to know the volume, and we have found it.